Hi everybody, we're moving on and we are at 4.4 using all three rules together. So in the last two videos we covered Ohm's law, Kirchhoff's junction rule, and then Kirchhoff's loop rule. So there are two Kirchhoff's rules that we're using, and then Ohm's law. So here we have Ohm's law, and it's written in all of its different forms to solve for voltage, resistance, and current using the other two variables. We have Kirchhoff's junction rule, and again, the amount of current flowing into a junction is equal to the amount of current flowing out. What we also learned before, if you have two components, two resistors that are on the same branch together in series with each other, and you know the current of one of those, then you know the current of the other one. Also, if the amount of current flowing into a junction is equal to the amount of current flowing out. The other concept, the other Kirchhoff's loop rule, the third rule is Kirchhoff's loop rule, which means the amount of voltage produced by a battery, which is going to be equal to the amount of voltage consumed by the resistor. And what we also learned is that if you know, what we also learned from the PHET simulation is if you know the voltage produced by the battery, then that is a voltage consumed by each resistor that, each branch in parallel with it. Okay? So, or if you know the voltage of one of those branches, then you know the voltage of the other one. So let's go ahead and go on to our first puzzle. Okay? And we're supposed to do find the resistance, current, and voltage of each component here below. We have a component R1. We have two resistors that looks like they're in series with each other. And we have a battery over here. We know the battery is producing 2 amps. We don't know the voltage here. Okay. We know this resistor R1 is a 1 ohm resistor. We don't know the current and voltage. We have a resistor R2. We know it's consuming 4 volts. We don't know the current and resistance. Oh, and here's a Sphinx cat staring at you, judging you. I love Sphinx cats. My wife had a cat called Zip, and he was a Sphinx cat. He would get sunburned, so he had to wear like a little sweater or t-shirt going around outside. So try not to look at the cat as you attempt to do this puzzle. So please apply all three of those rules below, and just I'm going to post Ohm's law in all of its calculations right here, so you could try it out. So go ahead and try it out right now and pause the video and try to see if you could fill these fillable areas. All right, hit pause now and try it. All right, we are back. So let's go ahead and try this. Well, I'm going to go ahead and use comments, and again, this pops out every time. I have to hit the little arrow button to put it back in place. I'm going to go ahead and map the current. We know the current coming out of the battery. We know there's a current of 2 amps coming out of the battery. And that means we know the amount of current going into the battery. All right. So if 2 amps is leaving, 2 amps is coming in. Well, that means 2 amps is coming across the top part, and 2 amps is going down across both of these resistors, and 2 amps has to be going through this bottom wire. So it should measure 2 amps across everything here. Okay, so this is 2 amps. Remember, current flows like water. This is Kirchhoff's rule. It's his junction rule. 2 amps is flying across here. 2 amps is going across there. And that means 2 amps is going across both of these resistors. And they're not sharing the 2 amps. It's water. So if 2 gallons of water is flowing through here, then that means the same 2 gallons of water has to be flowing across the resistor. So that means this is 2 amps. and this is 2 amps. Okay? And now that we know that, well, now we could apply Ohm's law. Since we know 2 of the variables here on this resistor, then we could apply Ohm's law and solve for the third. Well, we have resistance and we have current. We need to find the voltage. Well, looking at this right here, voltage is equal to current times resistance. So 2 amps times 1 ohm is going to be 2 volts. Okay? And that's Ohm's law. So now the same 2 amps is flowing across resistor number 2. That's 2 amps there. And this is 4 volts. So we know the current and we know the voltage. We need to get resistance. To get resistance, resistance is equal to voltage divided by current. So 4 volts divided by 2 amps is going to be 2 ohms. Okay? And now that we know all of the variables here, we could actually find out how much voltage the battery is producing. Okay? Well, R2 is consuming 4 volts, and R1 we calculated it to be consuming 2 volts. That means 4 volts plus 2 volts is going to be equal to 6 volts. Cool. All right. Let's move on to the other problem. All right. Again, same problem. We have to find the resistance, current, and voltage across all the components below. And here we have components that are in, we have 2 parallel branches. Okay? The battery looks like it is producing 3 amps. And we don't know how much voltage is being produced. What looks like R2 and R3 are in series with each other. We know R2 is 5 ohms, and we know R3 is consuming 6 volts. Okay. We know R1, which is parallel. It's in a branch that is parallel to R2 and R3, which is then in parallel with the battery. So we know R1 is getting 1 amp. So go ahead and pause the video right now, and let's and go ahead and try this new puzzle. Again, you got to try to use all 3 rules, and I'll just go ahead and post this right here. So go ahead in your notes, try to go ahead and do this. Okay. Pause the video now. All right, we're back. Well, again, I'm going to go ahead and I'm going to track the current. So we know the current is leaving here. And we know that's 3 amps. And that means there has to be 3 amps coming back into the bottom of the battery. Okay. So 3 amps has to be going up to this wire. And we know that a certain amount of that amperage, and since the current's going to split, I'm going to use a different color. I'm going to use green. And I'm going to use green for this branch that's going through R2. So let me put some numbers on this. This is 3 amps. And I'm going to go ahead and grab this. And we know that this is also 3 amps here. And that this 3 amps is coming up, coming over, and coming into this junction. And now we have a junction here with 3 amps coming in. And that means 3 amps has to be leaving the junction on the other side of the battery. It has to be leaving here. And coming back into the battery. So the current going across the second branch plus the current going across, I'm going to grab another arrow, going across here. I'm going to make this arrow a different color. using colored pencils or colored drawings. I like to do that. So here we go. We have a current coming in. It's splitting off into blue and green. So the current's flowing in, the 3 amps is flowing into this junction. One part of that current is flowing down, the other part of the current is going to the right across R1 and then flowing back into the junction on the other side. Okay. Okay, well, let's apply Kirchhoff's loop rule, or rule number 3. Actually, let's do the junction rule. I apologize. Let's rule number 2, which is Kirchhoff's junction rule. The amount of current flowing into a junction is equal to the amount of current flowing out. So 3 amps is flowing into this junction. And we know 1 amp is flowing blue, has to be 1 amp because it says it right here. Okay. Oops. So that means blue, since R1 is getting 1 amp, that means blue, that current, is 1 amp. And that means this is 1 amp, and that means down here is 1 amp. So 3 amps is coming into this junction, 1 amp is leaving. That means 2 amps has to be going to the bottom junction. Okay. So that means the green current is 2 amps. That means R2 is 2 amps. And R3 is getting 2 amps. It's great. By tracking, by using Kirchhoff's junction rule, we could track the current. So R2 is getting 2 amps, R3 is getting 2 amps, and now we could apply Ohm's law to solve for the voltage here. Ohm's law, voltage is equal to current times resistance. We have the current and we have the resistance. Current is 2 ohms, resistance is 5 ohms. Again, you have to get a whole number in these puzzles. And that means the voltage here is 10 ohms. 10 volts. 2 amps times 5 ohms is 10 volts. Let's apply Ohm's law while we're here to R3. We have 6 volts and 2 amps. How do we get the resistance here? Well, voltage divided by current is equal to resistance. So 6 volts divided by 2 amps, well, that's going to be 3 ohms. Okay? Well, the great thing is, well, now we know the voltage across this middle branch. R2 and R3 add together. R2 is consuming 10 volts. R3 is consuming 6 volts. Well, any branch that is in parallel with this, according to Kirchhoff's loop rule, which is rule number 3, those, if you know the voltage across one of those branches, then you know the voltage across the other branches. This is altogether 16 volts across this middle branch, and that means this loop right here, 16 volts, 16 volts, 16 volts, right there. So 16 volts there. And that means this is 16 volts here. This loop right here is going to be 16 volts. Okay. Well, now we know the voltage there. We don't know the resistance. We want to calculate that. So we need to do for R1, we need to calculate the resistance. Voltage divided by current. 16 volts divided by 1 amp is going to be 16 ohms. So now we just solved this puzzle the entire time while a grumpy Sphinx cat wearing he looks like he's sleepy. Sphinx cats aren't grumpy. They're just cute and sleepy. All right, anyways, we've just solved this puzzle. Let's move on. Let's do another one. Oh, he's cute. So let's do another puzzle. Again, I'm going to grab this and paste it here. Okay. We have a battery which we know is producing 14 volts. We have a resistor that is in series with two other resistors. Now, this is called a sub-parallel branch. Whenever you have a major branch and then you have two little guys that are in parallel with each other, this is a sub-parallel branch to this major branch. Okay, so R2 is in parallel with just R3. Okay, they're only in parallel with each other. This entire branch here is in parallel with the battery here. Okay, I just want to be clear on that. These two guys are only in parallel with each other. You can't say then that they're in parallel with the battery here. That wouldn't be, that's not right. The entire branch here is in parallel with the entire branch here. Now you know the battery is 14 volts, but you don't know how much current it's producing. You know R1 is 2 ohms, and R1 is in series with this branch right here. We know R3 is 6 volts. We don't know the current and resistance. We know R2 is 2 ohms. We don't know the current and voltage. So go ahead and pause the video and try applying all three of those rules together. All right, and go ahead and pause the video now. All right, how'd you do? Again, you need to get whole numbers for everything. If you get a decimal or a fraction, then you made a mistake. Well, I'm going to try to go in order. Ohms, for me to do Ohm's law, I need to know at least two of the variables here. So I can't do Ohm's law here. I only know one variable here. Can't do Ohm's law there. Can't do Ohm's law here. Let's move on to the second rule, and the second rule is Kirchhoff's junction rule. That means the current flowing in is equal to current flowing out. That means I need to know the current somewhere on these things. I don't know the current here, the current in R1. I don't know the current in R2 and current in R3. So I can't do that. Well, let's move on to the third rule. Okay, third rule, I need to know some voltages. Okay, I know the voltage of the battery, but I don't know the voltage across this entire thing. I know this is producing 14 volts, and that means this entire thing this whole branch has to be producing consuming 14 volts. Well, what we had learned is that if one of the consequences of this of Kirchhoff's loop rule is if you know the voltage of one thing and it's in parallel with the other, then that means they have to have the same voltage. Well, we know the voltage R3 is 6 volts, and it's in parallel in this little small loop with R2. Well, if this is 6 volts here, R2 has to then be 6 volts. So I'm going to go ahead and type in 6 volts right there. Okay, and that's the little loop rule. Okay, well, if this is 6 volts, we're going to apply Ohm's law, 6 volts, and that's 2 ohms. 6 volts divided by 2 ohms is going to be 3 amps. So now we know this is 3 amps. Okay. Whenever, just as a rule, what I like to do is whenever I get two of the variables, I just quickly solve for Ohm's law. You didn't have to do it, but it's good to do that. Well, what we had learned from the end of 4.3 of lecture 4.3 is that two things in parallel, basically, that's not 6 volts plus 6 volts, so this is a total of 12 volts. That's not what happens. I know it's kind of a little bit weird, but this is only 6 volts and this is 6 volts, so altogether this is just consuming 6 volts. Okay? Because what we had learned is we had two resistors that are in parallel with each other. I believe it was 18 volts and 18 volts. 18 volts plus 18 volts was 36 volts, yet the battery is only producing 18 volts. So it's this altogether is just 6 volts. It's not 18 volts plus 18 volts or 6 volts plus 6 volts. It's just 6 volts altogether. So that means the whole branch we know is 14 volts because this whole branch is in parallel with the battery. Well, this whole branch is 14 volts, but 6 volts is being consumed by R2 and R3. That means the rest of that 14 volts, which is 8 volts, 8 plus 6, yep, 14. That is what R1 is consuming. Okay. Well, since I have two variables now, I'm gonna go ahead and apply Ohm's law. 8 volts divided by 2 ohms is going to be 4 amps. Well, now we know this is 4 amps flowing through here, and now we could track the current. Let's go ahead and I'm going to use red for the major voltage. Coming out of the battery. Well, we know 4 amps is going across R1. Well, this came out of the battery just along one wire. So there's one wire leaving the battery, one wire going across, one wire flying down. And we also know that it's going to be one wire coming back in after we get to the junction. So basically what I'm saying is this: if this red guy, which is our current, is leaving the battery, so this red guy is coming across R1. Well, it only had one path to take, which is this path. Well, we know that's 4 amps. Well, that means this has to be 4 amps. What I'm saying is this red is 4 amps. That represents 4 amps. Sorry, kitty, you had to put that guy there. That means this current is 4 amps, and this current is 4 amps. Red represents 4 amps. So 4 amps leaves, 4 amps goes across. All 4 amps is going through R1. Okay, and when it gets to here, it's going to break off into 2 different currents because we have here it gets to a branch where it splits into 2 different currents. So I'm going to grab one of these arrows and I'm going to call it green. So green is going across going down so green had a bit of a hard time drawing that. So R3 has a current that's, R1, 4 amps is flowing into this junction. You have a green current that's flowing through R3, which is different than the current that's going to be flowing through R2. Having a hard time with these little arrows. Here we go. And then I'm going to draw another current. And that's going to represent the R2 current. And I'm going to give that a blue color. Okay, so R2 is going to be blue. So red is flowing in. Blue is traveling to the left across R1. And then joining up back with green to become red again. and then flowing back into the battery. So 4 amps is coming out. Blue, we know the current here, blue has to be 3 amps. Okay, so 4 amps is flowing in, 3 amps is flowing to the left, and that means, I'm going to go ahead and call this 3 amps. So 4 amps is flowing down, 3 amps is flowing to the left. That means the rest of that 4 amps has to be flowing through the right, which that is going to be 1 amp. So that means R3 is getting 1 amp. 6 volts divided by 1 amp is going to be 6 ohms. And then 3 amps is flowing to the back to the right, joining up with the 1 amp flowing back to the left to form 4 amps again. And so that is this. That is this little guy. All right. Now we are on the lecture tutorials. So what I want you to do is I want you to go through the lecture tutorials, and I want you to go ahead and try to solve this puzzle. Again, go ahead and take this little math trick. Pretty soon that multiplication stuff is going to be second nature, because you know it has to multiply up to a whole number or divide up to a whole number. So you'll go ahead and do that. All right. So go on to the lecture tutorials and go to this page. All right. When you do that, what I want you to do is I want you to go ahead and put your name at the top right corner. First things first. And I'm doing it in all caps, just because I'm silly. All right. And I want you to go ahead and try this problem. This is Kirchhoff. There should be 2 H's there. Whoops. Kirchhoff and Ohm's Law 1, 3.13. All right. So here we have a battery that's producing 8 amps and is producing 12 volts. We have a resistor A that is in parallel with it, and it is 3 ohms. We have resistor B that is in series with a resistor C, and this is getting 2 amps, and we know this is consuming 4 volts. And we have another branch, which is in parallel with the BC branch and parallel with the A branch. We have branch DE that is, we know D is 2 ohms, and E, we don't know any of it. So go ahead and pause the video, and I want you to try this out. All right, here we go. So we know 8 amps is leaving. Okay. So I'm going to start off with, I'm going to go ahead and start off with the Kirchhoff's junction rule. Okay. And again, I'm going to be using a red current. All right. We know this red current is going to be 8 amps, because the battery is 8 amps. And we know that 8 amps is flowing to the right, and it gets to this junction. Okay. And that means that when it leaves this junction at the bottom, it has to also be 8 amps. So red is representing 8 amps. So 8 amps is coming in, it hits this junction, and then a certain current is going to travel out to the right, and then it's going to hit a second junction and split in that, whatever that is going to split in half. Okay, here we go. So let's we could also apply Kirchhoff's loop rule here too, because this is 12 volts. That means anything that is in parallel with it as a consequence of that loop rule, anything that is in parallel with it, any branches that are in parallel with the battery, have to also be 12 volts. That means this branch A is 12 volts, the BC branch is 12 volts, and the DE branch is 12 volts. Well, let's start off with A. So we know 12 volts here. Here's a loop. That means this has to be 12 volts. Okay. Anything that's rule 3, the consequence of rule 3. That means that means we could actually now apply Ohm's law here and solve for the current. Well, current is equal to voltage divided by resistance. 12 volts divided by 3 ohms is going to be 4 amps. So that means we have a clue into how much current is going through this. That means this blue guy that we're going to be using here is 4 amps. So we know 8 amps is coming into this junction, and that means we know that this current that is leaving has to be the rest of that 4 amps. 8 amps is coming in, 4 amps is traveling down here, blue is 4 amps, and that means green has to be 4 amps as well. Because 4 amps flowing in, 8 amps flowing in, 4 amps heading down, 4 amps has to be heading across. Okay? And that means 4 amps has to be heading down on this bottom branch guy too. Okay. So now we have that. So 8 amps flows in, 4 amps leaves, 4 amps heads down, joins up again with the green 4 amps to make 8 amps. Well, now we have a second junction, okay? So we're going to have to use some more colors here. Let's try yellow. Actually, let's try orange. Warriors orange. Oops. I'll have to replace that green arrow in a second. Draw that out in this guy. Okay. So green is coming in to the second junction here, and we're going to call this pink. Yep. We're going to make another arrow called pink, and draw it down across the BC branch. So BC is going to be pink. That looks orange. I have to make it pink. Okay. So the BC branch is, so green is flowing in, which we know is 4 amps. Pink is traveling down, and orange is traveling across. Well, B and C are in series with each other. And rule number 2, which is Kirchhoff's junction rule, well, the consequence is if you know the current of one resistor and it's in series with another resistor or series with another element, then that has to be the current through there. So we know B is 2 amps. That means C has to be 2 amps. What that means is that pink is 2 amps. Okay? So pink is 2 amps. Right? Let's quickly do this. C is going to be, well, we know 4 volts and 2 amps. That's 4 volts divided by 2 amps is 2 ohms. Okay. While we're here, let's go ahead and we know 4 amps is flying into this, 2 amps is traveling down, and that means 2 amps has to also be orange as well. They're a different 2 amps, but they add, it's not the same 2 amps. They look like, just like this one, they're 2 different currents. They just happen to be the same numbers. Okay. Well, we know that that orange guy is flying down, and only that orange guy is flowing across DE. And that, since we figured that out, that's 2 amps, that means D has to be 2 amps and E has to be 2 amps. 2 amps times 2 ohms is going to be 4 volts. Oops. There we go. All right. Now we could apply the third rule, which is Kirchhoff's loop rule. Well, this loop, which is a big loop, the BC loop, is right there. We could do that as a loop, or we could do this as a loop. Either way, BC is in parallel with the battery. That means this is 12 volts. This has to be 12 volts. Well, we know 4 of those volts is there, so the rest of that 12 volts has to be here. 8 volts plus 4 volts adds up to be 12 volts. And now we could find the resistance using Ohm's law. Voltage divided by current. 8 volts divided by 2 amps is going to be 4 ohms. And we could do a similar thing that we just did using Rule 3 for DE. DE is in parallel with the battery. We could also use this loop too to do it. We could do the larger outside loop, or we could do this inside loop, or we could just simply use a consequence of the third rule, which if this is in parallel with this, the voltage here is the voltage here, is the voltage here, is the voltage here. So that means this is also going to be 12 volts. 4 of the volts is there. That means this has to be 8 volts. 8 volts divided by 2 ohms is going to be 8 volts divided by 2 amps is going to be 4 ohms. All right, that is the first puzzle. I want you to go ahead and try all the rest of the puzzles on Kirchhoff's and Ohm's Law 1. All right, good luck.